Welcome all of you to this second lecture on earthquake engineering. In last lecture, we have studied the internal structure of the earth. You can see the link in the description box or you can click on the I button. In this video, we are going to cover continental drift theory and plate tectonic theory in very simple language. So let's begin with continental drift theory. So this theory was proposed by Alfred Wegener in 1915. So he presented one hypothesis. What was that? The continents, here the continents means land masses. Okay, I'll show you land masses. So the continent had once formed a single landmass before breaking apart and drifting to their present locations. Let's do understand what is that hypothesis. So here you can see the present locations of the continents. So these are the continents: South America, North America, Europe, Asia. Okay, likewise Middle East, Africa, Australia, all are these are continents. Means what? Land masses. There is a land. Okay, so as per Alfred Wegener hypothesis, he says that around 200 million years ago, all these land masses were together. Here you can see this is the today's position where land masses are away from each other. Okay, but as per Alfred's hypothesis, he says that 200 million years ago, all these continents were together. Okay, so why he said like that? Because he had some observations. The observation is he found similarity of coastline, geology between South America, Africa and Indian Peninsula, Australia and Antarctica. What does it mean? Let me show you with image. So he says that whatever fossils and geology he found on South America, Africa, Antarctica, Australia were same. That means they were together. That's why you will find the fossils, okay, same. Also he given another reason that if you see the South America and Africa, they fit into each other like a puzzle. Okay, we solve the puzzle. Okay, we fit different things in it. Okay, like that he says that this South America is fitting with Africa. That means previously they were together and now they have apart from each other. So his observation was South America and Africa boundaries are matching together. Okay, in summary, I can say that Alfred Wegener in 1950 presented his continental drift theory. He said that 200 million years ago, there was only one continent, only one landmass that he called supercontinent Pangaea. He given the name to that supercontinent Pangaea and remaining was ocean. And that ocean he gave the name Peninsula's. So that continent he gave the name Pangaea and for that ocean he gave the name Peninsula's. So he says that over the period this Pangaea broke apart. That means all these continents drifted away from each other. Initially, his idea was dismissed, but that was the base for modern day's plate tectonic theory. We are going to see what is plate tectonic theory in later slides. So why Wegener's theory was dismissed? The reason is he was unable to provide a convincing explanation for the physical process which might have caused this drift. Means what? As continents drifted, that means some force is required. So he was unable to give the reason that why the continents drifted. He gave He gave few reasons like centrifugal pseudo force of Earth's rotation. Means Earth is rotating. That's why because of centrifugal force these continents drifted. Also he has given the reason like some astronomical precision. But after calculation, it was found that these forces were not sufficient to cause the continental drift. That's why this theory was rejected. Means whatever calculation, whatever reasons he had told, the calculation shown that the force is not enough. So at that time people rejected this theory. After that in 1960s, a new theory was proposed. In that theory, very important this statement that the lithosphere, I have told what is lithosphere in our lecture on internal structure of Earth. So lithosphere is broken into seven large and several small segment plates. Means what? If we see this is suppose the cross section of the Earth and this is lithosphere. Suppose this is lithosphere, then this lithosphere is not continuous. It is broken into several plates like this. So this is a different plate, 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 and this is a different plate. As per plate tectonic theory, they said that this Earth's lithosphere is not continuous, but it is broken, and this is generally 100 kilometer depth, and if we see width wise they are around 500-600 kilometer. So here you can see the tectonic plate map of the world. So this theory says that there are different plates like this. So this is one plate, okay, then this is another plate. Likewise there are several plates, okay. This is what we have covered in our internal structure of the Earth. So they said that the rigid lithosphere shell is broken into several irregularly shaped major plates and large number of minor or secondary plates, and these plates are not stationary. Very important. As I told you, as I shown you that these plates are not stationary. Actually they float in a complex pattern, and generally the velocity is 2 to 10 centimeter per year. Okay, that means those plates are floating. So here there is a semi-solid. Because of movement of this semi-solid, the plates move relative to each other, and generally the speed is 10 to 10 centimeter per year. Now, again, this theory requires a source that can generate tremendous force that is acting on plates. That means why this plate moves. So the reason is convention current. Convention current created by thermomechanical behavior. What does it mean? Let me show you. Generally, what happens in the interior of the earth, the colder and denser layers generally sinks under the action of gravity. When they go down, they get heated because as we go down in the earth, the temperature increases. So here the the less denser material rises upward like this. So this process goes on continuous. Okay. So here you can see, so this cycle is continuous, and because of this, these plates gets dragged relative to each other. So this is what happened. This is what it reason behind the movement of the plate. Because of the motion below the plates, they drag the plates. So next is plate. Here you can see these convection currents create shear stresses at the bottom of the plate which drag them along the surface of the earth. So here you can see as the plate glides over the asthenosphere, we have seen what is asthenosphere. Below lithosphere there is an asthenosphere. The continents and ocean moves with it. Because the plate moves in a different direction, one plate moving in this direction, one plate is moving in that direction, because of that they knock against their neighbor at boundaries. That means suppose this is one plate, this is another plate, so these plates move relative to each other. Okay, and the great force thus generated at the plate boundary and mountain ranges, then volcanic eruption and earthquake occurs. So all this happening because of the interaction of these plates with each other. So interaction of plates is the reason. Okay, so most of the earth's major geological activity occurs at the plate boundaries. So mostly what happens, suppose this is one plate and then this is another plate, so most of the geological activity occurs in that region where there are plate boundaries are there. Again there was a proof of map of distribution of earthquake epicenter around the world. So when epicenters were plotted, they you can see here that most of the epicenters are near the plate boundaries. Okay, so that was one kind of proof that whatever activities are happening are near the plate boundaries. Now next here is the earthquake that occurs at plate boundary is known as interplate earthquake. Means those earthquakes are occurring at the plate boundaries or near the plate boundaries. Then we called it as a interplate. And the earthquake which are occurring away from the plate boundaries are called as intraplate earthquake. The recurrence time for an intraplate earthquake is much longer than that of interplate earthquake. That means intraplate earthquakes are rare, interplate earthquakes are frequent. Now, there are three types of plate tectonic boundaries. Just a minute. I just switch on the. Okay. Now here you can see there are three types of plate boundaries. First one is the convergent boundary, second one is the transform boundary, and third one is the divergent boundaries or spreading reach. Let's see one by one what is that. So convergent boundaries means boundaries or the plates are moving towards each other. Then we called it as a convergent boundaries. Next one is the transform boundaries. Means when plates move relative to each other, we called it as a transform boundaries. And when plates move away from each other, then we called it as a divergent boundaries. Now, in case of convergent boundaries, let's see what happen. In case of convergent boundaries, two plates move towards each other. So two plates move towards each other. So what happen when two plates, suppose this is one plate and there is another plate, and so in this case one plate may get sink below the another plate. That is the first case. So one plate may get below the another plate, or they could collide, or they could collide with each other. So these two cases can happen. So when one plate move downward or sunk, then these boundaries are called as subduction boundaries. So ocean convergence, ocean continental convergence, at that time there is a subduction boundaries. Means what? One plate will go downward to the with respect to another plate. So the junction where two plate meets, a trench known as oceanic trench is formed. So here you can see one plate is going or getting sunk below the another plate. So there is ocean convergence, ocean continental convergence. So generally those plates are heavy or highly dense, they get sunk, and that zone is called as subduction zone. So generally there is a volcanic activity, because when plate goes downward, there is high temperature, so this portion gets melts, and because of that there is a volcanic activity. Next, convergent boundaries, in that collision boundaries, B part. So when two plates with continental lithosphere, means land masses lithosphere, collide, at that time subduction ceases. Means what? Subduction gets stopped, and a mountain range is formed by squeezing together and uplifting the continental crust on both plates. Means what? When two continental plates move towards each other and collide, at that time there is a formation of the mountain range. So Himalaya mountain is formed between India and China in this way. So I will show you, because there is an interaction of Indian plate and Eurasian plate. So here you can see uh, there is a boundary. This is Indian plate and this is Eurasian plate. At the junction there is a formation of mountain range. So that is the reason behind the formation of Himalaya. Okay. Then there is a ring of fire present in the Pacific Ocean. 90% of the earthquakes are occurring in this region. So that is also one example. Next is transform boundaries. In transform boundaries, plates moves relative to each other. So here you can see one example of San Andreas fault. Okay, so when plate moves relative to each other, they may get stuck, and then when stress reaches beyond the strength, then there is a shaking, and because of shaking, there is an we call earthquake is there. Then divergent boundaries. So in divergent boundaries, spreading ridge, or it is also called as divergent boundaries, means two plates gets moved away from the each other. So in that process, what happened, whatever magma is there, it's coming out and it is forming a new crust, means new land is getting formed, new crust is getting formed. So here you can see in divergent boundaries, plates are moving away from the each other. So when they move away from the each other, whatever magma is there, it is coming out and it is forming a new crust. Okay. So this is the location where less dense molten rock from the mantle rises upward and become part of the crust after cooling. So here you can see divergent boundaries. Mid-Atlantic Ridge is a massive underwater mountain range located along the center of the Atlantic Ocean. And there is Iceland Rift Valley also, where two plates are moving away from each other and there is a valley. So this is all about what we can say causes of earthquake given by continental drift theory and plate tectonic theory. So in next we are going to see elastic rebound theory and the faults. So thanks for watching. Please like, share, subscribe the Real Civil YouTube channel. Thank you. Thank you so much.